We saw in the last video how buffers are resistant to a change in pH. So whether we're talking about a reaction that's running in our body or a solution that we're preparing ourselves, if we want to establish a buffer, there are certain requirements that need to be met. So the first requirement in order to establish a buffer, we must have a weak acid or base with its conjugate. So the first requirement says we need to have a weak acid or a weak base, and along with it, we need to have its conjugate pair. So if we have a weak acid, we need to have that acid's conjugate base in order to have a buffer. The same goes for a base. If we have a weak base, we need to have its conjugate, which would be a weak acid, in order to have a buffer. So the Ka / Kb values will range from 10 to the negative third molar to 10 to the negative 12 molar. So in order to establish a buffer, we need to make sure that we have a weak acid or base with its conjugate. And these Ka / Kb values, if they fall in the range of 10 to the negative third and 10 to the negative 12, we can ensure that we are dealing with a weak acid or base. This means that if we have a Ka or Kb value that is either much smaller or much greater, we are not dealing with a weak acid or base. We should note that if we have a strong acid or base, that is not going to form a buffer. So requirement number 2, so this goes with the fact that we need a weak acid with its conjugate base or a weak base with its conjugate acid. The ratio of base to acid needs to be within the range of 0.1 to 10. So in order to establish a buffer, the ratio between that conjugate base to that acid needs to fall within a range of 0.1 to 10. So as soon as we get 10 times as much base as we do acid, we are now about to break that buffer. In the same way, if we are now setting up a ratio where the base over the acid gives us a value of 0.1, anything below that number will now break our buffer. So we need a weak acid or a weak base with its conjugate with those Ka or Kb values within that range, 10 to the negative 3 to 10 to the negative 12. And we need a ratio of base to acid, which is in between 0.1 to 10. Our third requirement, the concentration of acid or base needs to be within the range of 1 times 10 to the negative 3 molar and 1 molar. So this simply means whatever solution we are setting up, if we have an acid or a base and it needs to be a weak acid or base, we just need to make sure that the concentration of that weak acid or base is anywhere from 1 times 10 to the negative 3 molar to 1 molar. Now we need that ratio of base to acid to fall within that range of 0.1 to 10. However, the individual concentrations need to be within this range of 1 times 10 to the negative 3 molar and 1 molar. So as we can see, in order to make a buffer, we essentially need a weak acid or base with its conjugate and essentially have a decent amount of the base and the acid to establish a good ratio between 0.1 and 10. And we can't have a concentration of that acid or base that's either way too big, which would be past 1 molar, or too small, which would be less than 1 times 10 to the negative third molar. So in the next upcoming videos, I'm going to be going over how to use buffers to solve problems and calculate the pH of a buffer using the fact that we know that we have established this buffer solution with these following requirements.